All right, I think we will start. Everybody has joined. Can you just confirm if my voice is audible? Okay, so let us start with waves. Okay, so basically, what is a wave? Any particular disturbance that is formed in a medium is known as a wave. For example, if you have a glass of water, right, and you disturb this, and you look from top, what you can see something like this, right? Similarly, if there is a pond or if there is a river, and basically in a river I don't think you can see, but if there is a lake, right, a standing water, and if you throw a lake, you can see that waves will be formed, right? So basically, if you disturb any medium, it can be liquid, it can be solid, it can be gaseous, those are waves, right? Now, these are waves. What are the types of waves that are important and what we study about here? They are known as progressive or mechanical wave, right? Okay, both are one and the same. So I'll write down over here progressive, or also known as mechanical wave. So what is such type of a progressive wave? It can be defined as a continuous propagation of disturbance. I will write down over here, it is continuous propagation of disturbance. If there is a continuous disturbance, then we'll be getting a progressive wave. If I just throw a stone, that will be just one off, right? It won't be continuous. So I cannot tell that it is a progressive or mechanical wave. But if I have a disturbance which is continuous, those type of waves are known as mechanical or progressive waves. Now I will draw the wave over here. Essentially, it is going to be a sine wave. We consider a sine wave, right? And we define amplitude and we define the equation as well, right? So the highest point, this one is known as your amplitude, and whatever the distance that it is going to travel, that is known as your x at this particular point, right? And what is your time period? The time taken for the wave to travel from this point to this particular point, this is known as your t. This is known as your t, and t is given by 1 divided by f. T is given by n divided by f. Now, we define displacement of this particular wave, right? So the displacement of this particular wave is represented by y is equal to a sine omega t. It is similar to what we have discussed before, right? It is the same thing, right? There we had plus omega t as well, but here it is going to be a little bit different. It is going to be a little bit different. So over here, this is going to be a general wave, right? But substituting for the value of the value of k, and here the k is known as your angular number or propagation constant, that I have to plug in this particular formula, right? And rest everything is going to remain the same. So let me write down over here angular wave number, or it is also known as a propagation constant, and it is represented by k. It is represented by k, and this k is given by the formula. K is given by the formula pi 2 pi by, or first let me write down omega divided by v. This is one of the relation, and one more relation is 2 pi, and here it is going to be v under lambda. 2 pi divided by lambda. This is known as your angular wave number or propagation constant, right? Now, what is going to be the phase? For that one, I will write down the entire equation now. So I will be getting y is equal to a sine omega t minus kx. And this particular value is going to represent the phase of the particle. So this is your phase. This is going to be your phase. Okay. Now there are yes, yes. This one, whatever it is, the change, right? There could be another, for example, sine of omega t, something else, kx, or some value will be there, right? So this particular value will represent the phase of that particular disturbance or that particular wave. Okay, I will tell you when how you can take up. Yes, yes, yes. Go on. Come again. Kx is it is not the change. No, no. K is the propagation constant. Okay, so sine omega t is the general wave, right? And this k multiplied by x, this will depend upon the medium. This will depend upon the medium. Okay, now no. The entire thing is going to be this will represent your phase. What do I mean by that is, if I have sine of some, say, theta, and if I have, say, sine of alpha, right? In that case, theta minus alpha, this is going to be representing your phase difference between these two. Okay, so generally I can represent whatever is inside, that is going to represent the phase, right? If there is only one, then there is no phase difference, right? You cannot have difference when there is only one wave, right? When you have multiple waves, only then you can have phase difference. Okay, now this is uh, for your x-axis, or let me write down over here, minus kx is there. So this is your propagation. I will write down, this is the propagation of wave along x-axis, or positive x-axis, if it is going this way, right? What if it is going in the reverse direction, right? If I have reverse direction, the only difference is here it is going to be positive symbol, so I can write this as y is equal to a sine omega t plus kx. This is going to be the propagation of wave along the negative x-axis. Okay, now apart from this, what are the relation that you have to know? The main relation is this one, y is equal to a sine omega t minus k. Usually we take up the right hand side only, right? Positive direction of x-axis, so usually it will be this. But they can, if they mention that it is going in the negative direction, it is going to be positive. It is going to be positive. Okay, now if you know these relation, the main relation is y is equal to a sine omega t minus kx, and what is your k? K is known as your wave number. It is your omega divided by the velocity, or you can write that as 2 pi divided by lambda. Lambda is your wave length, whatever this length is there, right? This particular length, that will be your lambda. This is going to be your lambda of one wave. You can measure from here to here, or you can measure, if this goes on like this, you can measure from here to here as well. This is going to be your lambda. So 2 pi divided by lambda is going to give you k, and k is your propagation constant. Okay, and what is your x? X is the distance at any point. No, sorry, not distance, displacement at any point, say at this particular point, this particular point, at any point, that will be plugged in over here. T is your time period, omega angular frequency. Anyway, sine is your trigonometric ratio, right? And what is your a? A is your amplitude. Y will be giving you the displacement along y-axis, along y-axis, right? This will tell you where the particle is. It is over here, here. Where is it? Now, if you know this much, we can start solving the problem. And one more thing also I will plug in, right? And what is your omega? We know that omega is 2 pi f, and omega can be written down as 2 pi divided by t as well. Now, if something is related with k, if propagation constant is given and frequency is asked, I can easily find out. If time period is asked, even that can be found out. Why? Because time period and frequency both are related with angular frequency, and angular frequency is related with the propagation constant, right? Similarly, if wavelength, if something is mentioned with the wavelength, I can easily solve. Okay, now however, the general formula based question will be given, that is the equation based question will be given. So that one I will discuss first. Okay, then we have a relation based on temperature, I will take up that, and then we'll go to Doppler effect. So this is the first question that I will be solving from this particular chapter. Okay. The equation of the plane progressive wave is given by y is equal to 2 sine phi pi t minus 3x. What is the time period of the wave? T is measured in seconds and x is measured in meters. Right? So what is the time period of the wave? This is what we have to find out. So how can we find this out? Any idea? First, I will start by comparing the equation, right? So here y is equal to 2 sine multiplied by phi pi t minus 3x, right? What is asked? What is the time period? And how is time period related? I can take up this one, right? Can I write as t is equal to 2 pi divided by omega? Yeah, I want the value of t, so I know that t can be written down as 2 pi divided by omega, right? Can I find out what is your omega? Yes, I can. What is the general equation over here? Y is equal to sine a sine multiplied by omega t minus kx, omega t minus kx. Now comparing both of them, you will be getting the value of a. What is the value of a? The value of a is 2. What is the value of omega? It is 5 pi. And what is the value of k? K is going to be equal to 3, right? Because negative sign and negative sign, it will be getting cancelled. So k is going to be equal to negative 3. Now can we find out the value of t over here? Yes. Yes, right? So I know the value of omega. So t will be equal to 2 pi divided by 5 pi, and divide this, you should be getting your answer. So t will be equal to point. Yes, it is going to be 0.4. This is going to be the right answer. I hope you have got it. Yeah, easy, right? Okay, okay, okay. Going to the next question. The equation of the progressive wave is given by y is equal to 2 sine pi t minus zero point 0.5 pi t. And it is given that x and y are in meters and t is in seconds. The velocity of the particle at t is equal to 1 and x is equal to 1. Right? I guess somebody is joining. Who is okay, fine. All right. So again, I will start by writing down the general equation. And what is the general equation? It is y is equal to a sine omega t minus kx. Y is equal to a sine omega t minus kx, right? And what is given over here? I can just compare both of them, right? So here it is y is equal to 2 sine pi t minus kx. Instead of kx, I have zero point 0.5 pi t x. I can just compare and get the values, right? Come on, come again. Ah, 0.5. I think the x is missing. The x should be there. X should be there. Okay, you plug in x, it should be there. I think that is why. Yes, yes, yes. Here you take pi xt. Pi xt you take. Okay, here I think x is missing because here it is mentioned, right, where x and y are in meters. If x is not here, why would they mention x? So I think x should be there. So it is going to be zero point 0.5 pi xt. Now you compare both of them. Comparing both of them, I can get the value of a. The value of a is 2, right? And what is the value of omega? Omega is equal to pi. And similarly, I can find out the value of x as sorry, k as well, right? So what is the value of k? It is zero point 0.5 pi and it is t. This is the value. right? Now what do we have to find out? I have to find out the velocity of the particle. And what is the velocity given by? What would be the velocity given by? It is v square is equal to omega squared multiplied by a square minus y squared, right? This is the value of velocity. Now I have to plug in the same values. I should be getting my answer. So what is the value of Vp? So V is equal to omega. I will write this as omega square root of a square minus y square, and omega is equal to pi. So pi as it is, and the square root of a square. What is your a square? A square is 2, right? So this is going to be equal to 2 squared minus. And what is your x over here? X is 1. X is, wait, what is the value of pi is taken? Okay, the value of x is over here. Is it given? X is going to be equal to 1, right? So k value, I can take this as, instead of taking 1, I can just take this as 0.5 k. Yeah, yes, right? Now, I will substitute, and what is going to be the value of y? So substituting, and I should be getting the value as 2 multiplied by, it is sine as it is, pi multiplied by t is 1, so pi minus 0.5 multiplied by pi, right? So it is going to be zero point 0.5 and pi. So when I simplify, y will be equal to 2 sine of pi minus zero point 0.5. So it is going to be zero point 0.5 pi. Yes. So now how can I find out the value of y? Any idea? Or this can be written down as pi by 2, right? So 2 sine pi by 2. What is pi by 2? Pi by 2 is 1. So 2 multiplied by 1, y is equal to 2. So y squared as in 2 squared again. Pi multiplied by square root of 2 square minus 2 square is what? It is 0. So it should be 0 is the right answer over here. 0 is the right answer. So the velocity of the particle will be 0. I hope it's clear, meaning that it will be at the extreme position. It will be at the extreme position. After 1 minute, it is going to be over here at this point. For an instance of time, the velocity will be equal to 0. And then again, it will increase, decrease, increase, decrease, and so on. Did you understand how we have taken this question? And again, I have told you the same formula we should be using. The general formula of the wave, a sine omega t minus kx, and the propagation constant k. Yeah, I hope it's clear. Let me go to the next question. A particle executing SHM on an acceleration of zero point 0.5 centimeter per second when the displacement is 2 centimeter, find the time period. Find the time period, right? So what is given over here? The acceleration is given, right? So that acceleration is minus omega square y. Yes, somebody is joining this. Yeah, yeah, Prajwal, you said something. Yeah, I think you have raised. What? Yes, again, I think there is a mistake over here. Yes, it should be second square area. Okay, and this is 2 centimeter. So this is the formula for acceleration, right? And now I can equate, and I can find out what is the value of t from here. Yeah, yes. So omega square. So what is your omega? Omega is given by 2 pi divided by t. I know that omega is 2 pi divided by the time period. Now I can plug in the same value. So a is going to be equal to omega square. I can ignore the negative sign, right? So over here 2 pi divided by t whole squared instead of omega squared, and that is multiplied by y. So y is as it is. Now what is going to be the value of t squared? I can easily find out. So a will be equal to 4 pi square divided by t square multiplied by y. I need the value of t because t is asked. right? So I can get the value of t square. So t square would be equal to 4 pi squared y divided by a. Upon solving this, I should be getting my answer. Yeah. Now, what is 4 multiplied by pi square multiplied by y? What is the displacement over here? It is 2 centimeters. 2 multiplied by 10 raised to the power of negative 2 divided by a. Right? So, what is your acceleration? It is zero point 0.5 and it is centimeter per second. So, zero point 0.5 centimeter. I should convert again. So, it should be zero point 0.5 multiplied by 10 raised to the power of negative 2. Yeah. Now simplify and you should be getting your answer. This is the value of t squared. Okay. So this and this would be getting cancelled. Anything else? Zero point 0.5. Okay. 8. 8 and it is going to be 16. So 16 pi squared is the value of t squared. So t would be equal to 4 pi. I think the options are not given, but t will be equal to 4 pi. Square root I have taken. I have taken. After taking the square root only t I have got, right? Here t squared, this is the value of t squared. I'm substituting over here. Okay. Now the next type of question will be based on the factors affecting the velocity of sound. So let us talk about velocity of sound in a medium. Velocity of sound. Sound is also a wave, right? Velocity of sound in a medium. And again here your Newton is going to come. We represented by the bulk modulus, right, or pressure. Both are one and the same. Where did that go? Not this one. Yeah. So the velocity of, or let me directly write down the formula. So the velocity would be equal to the square root of k divided by density, and this is also equal to root of p, where p is going to be your pressure and this is your density. Don't get confused here. This is your pressure, p is your pressure, and rho is your density. Rho is your density. Okay. And k is your bulk modulus. Bulk modulus. So usually in your numericals these will be given to you. So basically the velocity of sound will depend upon the pressure and bulk modulus, of course density as well. Okay. Now apart from this you have effect. Yes, effects on temperature. This is also very very important. Effects of temperature. Temperature um, on velocity. On velocity. So this is v is directly proportional to the square root of t. This is the particular relation that you have to know. Okay. And how are we getting this one? From your Charles law. From Charles law we'll be getting this one. Okay. Because what is your Charles law? I think I have told you p v divided by t. You start with t, keeping t constant, and this one, right? So v divided by t1, v1 t1 should be equal to v2 and t2. Yeah. Right. And what is your volume? I know that volume is r, or mass divided by volume is your density. So how are they related? They are inversely related. They are inversely related. So if this is inversely related and coming over here v and rho, they are inversely related, so both of the inverse will be getting cancelled. And how will it be related? Inside the square root, so v will be directly proportional to the square root of t. However, the derivation you need not know. You just need to know the main formula, how they are related. Okay. So these three are the main formulas over here on which most of the questions are asked. Now let us take up few questions from over here. Yes. The velocity of the sound in air increases by about dash for 1 degree in temperature. 1 degree, I guess it should be increase. Okay. You can take this as it is not mentioned, right? You can mention over here 1 degree rise in temperature. Okay. It should be rise. So the velocity of sound in air increases about dash for 1 degree rise in temperature. Fill in the blanks and the options are given to you. Right. So what do we know? I know that V is directly proportional to the square root of the temperature. Right. And over here, if it is increasing by 1 degree, then what is going to happen? That is what we have to find out. Right. So first it was this case, and now V dash is directly proportional to T plus 1. Can I write it this way? Yeah. Yes, right. Yes. Now you take the ratio, you should be getting your answer. So V1 divided by V2, V1 divided by V2, you should be getting your answer. Okay. So here I can write this as V and V dash. So this will be equal to the square root of, over here it is going to be T, and here it is going to be T plus 1. And now we have to plug in few of the constants. Right. So what are the constants that I can consider over here? Usually we consider at STP, standard temperature and pressure, right? Yeah. Yes or no? What is the standard temperature and pressure? It is 0, or I can write this as 273. 273 I can write down. So here it is going to be V divided by V dash is equal to 273 over here. And here it will be 4. Yeah. Better to take Celsius, then what will happen? Okay, Celsius also you can take 1, and then it is going to be 1 divided by 2 in that case. Yes. Or we should be taking in Celsius. Why should be taking in Kelvin? Because Kelvin is the unit, right? We usually represent it in Kelvin. It should be in Kelvin. Even though if it is given in Celsius, we should be taking it in Kelvin. Now you should be. Huh, yes, sir. No, no, no. Here, what is given? One. It is not 1 degree. Yes, 1 degree is how much? It is 274. Yes, yes. 1 degree rise in temperature. 1 degree rise is asked. Yes, 0 to 1. So it was 273. This is your standard temperature and pressure at STP. So from here, if I increase 1, I'll be getting 274. Now you should be getting your answer, right? And what is your, okay, here I think one of the constant is missing. One of the constant is missing. Okay. So V multiply, what is the value of V? You can find out the difference as well, right? You just have to find out the difference. That also you can be, that can be done. So here I will be writing down this way, right? So this was the first velocity. This is V dash, in the sense it is the second velocity, as in after the rise in temperature. Now what will be the change? Change in velocity is going to be your delta V. So delta V can be written down as V dash multiplied by minus V. V dash minus V. Right. Now what is your V dash? How can I write V dash as? Can I write V dash as square root of 274 divided by 273 multiplied by V? Yeah, I'm just transferring this to the other side, and the reciprocal is multiplied to the left hand side. Now delta V is going to be equal to V dash. What is your V dash? V dash is this one, square root of 274 divided by 273 multiplied by V. minus v. So I will take v common over here. So v, if I take common, I should be getting square root of 274 minus divided by 273 minus 1. Okay, now this should give the right answer, right? So this can be written down as v is multiplied with 274 divided by 273 whole raised to the power of half minus 1. You have to find the square root of this particular value, square root of this particular value, right? So I think I will need a calculator over here. One second. Yes, yeah, calculator is taken. It is 274 divided by 273, right? 1.0036. So this one I have to take the square root of. So this is the value that I'll be ending up with, right? And this I have to subtract with 1, and then I have to multiply it with v. What is your v? V is going to be the velocity of sound. Yeah, I hope you're getting it. No, 273, 274 over 273 under the square root minus 1. Shall I do it again over here? It is, I will cancel all of this. So it is square root of, I will open up the bracket. I think it got cancelled, is it? 274 divided by 273, and here it is under the square root, and here it is minus 1, multiplied by v naught, and what is the velocity of sound? It should be 330. Are we getting it somewhere around wait, 320? Nah, something is wrong. I will check again. mm, have we substituted properly? One is 274, 273. Y is equal to the difference. Yes, 274. 274 divided by 273 minus 1. Hmm. Or if I 330. So 330, this is a small value, right? Again, I will check. So it is 274 divided by 273, and this should be under the square root minus 1 and multiplied by 330. Ah, yes, we are getting it. What is it? Zero point 0.6. Do we have zero point 0.6? Yes, zero point 0.6 is there. Okay, so this will be the right answer. So this is 330 meter per second over here. This is per second square. This is the velocity of sound, right? This you multiply by this value, you should be getting your answer. Okay, I think you'll be needing the calculator for this. Did you understand how I did it? But yeah, how do you find the value of v is a constant. It is 330 meter per second square in air. Actually, it will be given to you. And first, as you open up, there will be a full sheet of paper where all the constants will be mentioned, right? We can refer it from there. But however, it is good that if you know it is 330 for your sound. I mean, in your air, the speed of sound is 330 meter per second square. Okay. Again, here we are using v is proportional to the square root of t, the same formula. Now, let us come to the next question. The increase in speed of sound on increasing the temperature of the medium by 10 degrees will be. How can you solve this one? It is similar to the previous question, right? Similar to the previous question. Here, can I use the previous question only to solve this question? Yes. Here, I know that it in how many, for 1 degree, it is 0.61, right? This was the right answer. Or I can take this as zero point 0.6 meter per second square, right? Now if for 1 degree it is zero point 0.6, for 10 degree it will be how much? You just have to multiply. Yes, it is going to be 6. It is going to be 6. I can solve this directly because I have solved this. But if I have not solved this, then how do I solve? Again, the same method you have to consider. Again, the same method you have to consider. Right? But the only difference is now it is going to be 273 and 283. 283. Okay. So v proportional to the square root of t. So v dash is going to be proportional to what? It is going to be t plus 10. So standard temperature and pressure. So this can be taken as 273. And what is your v? V is 300. V is 300. Now you substitute, you should be getting your answer. So v divided by v dash is equal to the square root of 273 divided by square root of 283. You take the change. Yes. 330, 330, sorry, 330. It is 330. I had taken 330, right? Yes, it should be 330. Okay. So now you take the change in V. The change in V is V dash multiplied by minus V. And now from here you can find out the value of V dash. V dash is going to be equal to square root of 283 divided by the square root of 273 multiplied by V. Plug in the same value over here to find out the difference. So delta V will be equal to V. What is your V? Here I can make a note. 283,273 V minus V. And now I can take V as a constant, right? And I can take it common outside. And here I will be getting 283 divided by 273 minus 1. Again, I will go back to the calculator. Where is it? Here, right? So 283 divided by 273, and this one under the square root, and minus 1, and over here this one should be multiplied with 330 should to get the answer. So 5.98, 5.98 as in almost 6, right? It is visible, right? Whatever the calculator, is it visible? Okay.
Yes, sir.
So 5.9. So close to 6, right? Almost close to 6. However, you can solve it this way. But if you already have solved this one, you already know that for 1 degree it is zero point 0.6. So for 10, it should be just multiplied by 10. You will be getting your answer. Or you substitute, you should be getting your answer this way. Okay. I hope you are able to understand. Come again? Yes, yes, yes. You can just check. So for example, what will happen? 273 you take, 293 you take, right? So again I can show using the calculator real quick, right? Because it is not going to take much time. We already know the formula. Let me take this over here, and let me take this. Where is it? Calculator, where did it go? Yeah, here it is. Right now it is 293 divided by 273, right? And this one under the square root. Okay. I think I have to do it again. I'm sorry. So it is 293 divided by 273 is equal to this much, right? Now this is under the square root, and minus 1, right, is equal to this much multiplied by 330. So 11.8. 11.8 as in close to 12. Yeah. Okay. Let us go to the next one. This is we again similar question. If it is increased by 15 degrees, then what is going to be the value, right? Even this one we will solve, right? So what is given over here, or what do we know? We know that v is directly proportional to the square root of t, and here the velocity of sound in air at 15 degrees is v1. So I will write down over here, v1 is directly proportional to 15 degree, as in I should be taking 273 plus 15, 15. Yes. So v1 is directly proportional to square root of 288. I will put a box around it. Okay. Now if the temperature is doubled and the pressure is half, the velocity v2 then V1 is to V2 will be what? So here what is asked? Pressure is halved, right? But pressure is halved or pressure is doubled. Does it really matter about for velocity? No, because in the formula V is not dependent upon velocity pressure at all. So we just have to double the temperature. So I can write V2 is directly proportional to 2 multiplied by 288. Right? Now we should take the ratio and we should be getting our answer. So V1 divided by V2 is equal to square root of 288 divided by, here let me write this down as square root of 2, or I will keep it as it is. I will not multiply. Okay. Can this be written down as square root of 2 multiplied by square root of 288? Now it is going to be easier to get cancelled, right? So what is your V1 divided by V2? It is 1 divided by the square root of 2. This is going to be the right answer. And do we have this anywhere? Yes. C is the right option. I hope this is clear. Yes. And now coming to the last and main topic, that is your Doppler effect. Right? So what is your Doppler effect? It is the apparent change in frequency of sound, light, or any wave as the source, observer, any one of them or both move, and again in any direction towards each other or away from each other. So this is basically your Doppler effect. But there is only two formulas that you have to know. If you know those two, all the problems you can solve easily. Okay. So for that one, I'll be writing down two cases. Right. One is when they are approaching each other, and one is when they are moving away from each other. Okay. There are only two cases, right? And if one is given at rest, v can be taken as 0. So special formula you need not remember. Only two formulas you have to remember. So let me write down over here case 1 and case 2. So first is when source and observer are approaching each other. So let me write down over here A, right? So when source of sound and the observer or the listener, right, all are one and the same. Source and the listener, source and observer or listener both are one and the same. Okay. So source and listener are approaching each other, approaching each other, each other, as in they both are in traveling in opposite direction. Now for the second one, I'll be taking down source and listener are mm, moving away, moving away from each other. Okay. Now I will write down the formulas for both of them. Here what is going to be the change in frequency that is represented by f dash, and it is f multiplied by v plus vl. V plus VL, where V, just V is velocity of sound, VL is velocity of listener, V again is going to be the velocity of sound, Vs is the velocity of the source. Similarly, for this one, it is F dash is equal to F is the frequency, and this is multiplied by, now it is going to be ulta, meaning that V minus VL divided by V plus Vs. Both are one and the same. What is the difference over here? The only difference is here it is plus minus, here it is minus and plus. Is it clear? So these two are the main formulas that you have to know. Right? Now let me write down what all of this indicate. So what is your f? F is just your frequency. F dash is the apparent frequency. It is the apparent frequency. And what is your v? V is velocity of sound. And what is your vl? Vl is velocity of listener, and vs is velocity of source. Source as in some horn or any vehicle is moving, that is taken as source, and any person is that is taken as listener. So only two formulas you have to know, right? From this itself you can make other formulas. For example, if source is traveling, is coming towards me, right? So let us solve a problem over here. Okay, for example, I am here, right, and there is a train coming, and say this has a frequency of 300 hertz, and this has some velocity as well, right? Now what is the frequency that I will hear? That is your f dash. So how can I calculate f dash? The source and listener are approaching each other. As in now my velocity is 0. So VL will be equal to 0. So my frequency, the frequency I will hear is f dash is equal to f multiplied by V divided by V minus Vs. So this will be the frequency that I hear. Now if I'm also traveling with say 10 meter per second, then here you can plug in plus 10 meter per second square. Okay, are you able to understand? Okay, now another example. Now if the train is stationary and I'm traveling in this particular direction, in that case what is going to happen? Vs will be equal to 0. Vl is going to be my speed. And if the train is over here and I'm running away from the train, in that case again vl can be taken as negative, and here it is going to be vs is going to be equal to 0. Okay, is it clear? So only two formulas you have to know. If you know two formulas, everything you can solve any problem. There can be four cases, right? When both source and listener are moving in the same direction, both are moving in opposite direction. One is stationary, one is moving, approaching another one, and another one is stationary. The source is approaching listener, and here source is moving away from the listener and listener is stationary, or source is stationary and listener is moving away. So all the cases, just by taking two formulas you can find out. Is it clear? Now I will take up few problems so it will be clear for you. Okay, now let us write down, where did the problem go? Okay. Fine. So let me write down the problem real quick. Okay, I think it is not here. A source of sound wave, a source of sound wave moves towards a stationary listener, a stationary listener with speed of 1% that of sound, 1% that of sound, if the frequency of sound from source is, let us take something easy, 550 hertz, 550 hertz, then the frequency of sound heard by the listener is what? Then frequency heard by lis yes listener is what? Right, there can be few options given to you, but I will solve it directly. Right, so now what are the things which are mentioned? It is mentioned that it is moving towards. So which is the formula that I have to consider over here? Which is the formula? Option A as in first one. Yes, correct. F dash is equal to f multiplied by v minus vl, stationary listener, as in vl will be equal to 0. Yeah, so I can write this as f multiplied by v minus vs. Sorry, here plus, yes, But we anyway, VL will be equal to 0, right? Yeah. So this is the formula essentially that I have to consider. Vs is equal to 0 because stationary listener, as in Vs, so sorry, Vl will be equal to 0. Listener, Vl, listener. Okay. Now, what is given? A source of sound moves with a velocity 1% of that of sound, 1% of sound. So what can be written down over here? Vs is 1% of V. So 1% as in 1 divided by 100 multiplied by V. So which is V divided by 100. So Vs is equal to V divided by 100. Now let me substitute this over here. I should be getting my answer, right? So what is the value of f dash? F dash is f. What is f? Ff is 550, right? So it is 550 multiplied by V, multiplied by V as it is, divided by V as it is again, minus over here. What can be written down? It can be written down as V divided by 100. Now I have to solve this one. So again it is going to be 550 as it is, and V as it is, and here it is going to be 100 V minus V divided by 100. Yes, V can be taken as common. So 550 multiplied by V, and this is divided by V multiplied by 100 minus 1 divided by 100. Now this V and this V can be cancelled out. So the answer is going to be 550 multiplied by this 100 is going up, divided by this is coming down, which is 99. So 550 multiplied by 100 divided by 99 will give you the final f dash value, right? And again I will go back to the calculator. Here we are. And what should be the answer? 550 multiplied by 100 divided by 99. So 555.5. So 555.5. This will be the apparent frequency. Is it clear? Yes. Okay. Now let me take up one more. Hmm, go on. It can. Ah, yes. Yes. What is your frequency? Frequency as in how many waves can travel in 1 second in unit time. So either it can be greater or it can be smaller based on velocity. That is what your Doppler effect says, right? Doppler effect says that there can be increase or decrease in the frequency of sound, light, or any waves for that particular matter as your source and observer move. That is your Doppler effect, right? And these are the main two formulas that you have to know in order to solve. Okay. I hope yeah, I hope it's clear. I will take up one more question. Okay, let us take up one more question over here so that it's okay. Uh, choose it. Okay, let us take up this question. An ambulance blowing siren, blowing siren of frequency. I will write down directly. Okay, F is equal to 700 hertz. Is is traveling with the velocity directly. I will write down again. So it is 2 meter per second. 2 meter per second. Okay, towards vertical reflecting wall. So ambulance, what is the ambulance here? It is going to be source, right? So vs I will write down, vs I will write down, towards a vertical reflecting wall, vertical reflecting wall. If speed of sound, if speed of sound, so v is given as 352 meter per second, right? You should find out, mm, what is the difference in, what is the difference in apparent and actual frequency. Okay, so this is the question. I hope you have understood. Now I will start taking up the solution. So basically, what I have to find out, I have to find out the difference. Delta F I have to find out. That is your F dash minus F. So the difference between the apparent frequency and the actual frequency is what I have to find out. Yeah. Now, do I know the formula? Yes, I know that F dash is given by F multiplied by, here it is going to be V plus Vs divided by V minus VL. This is the formula, right? Now F dash minus FL. So this is the value of F dash. So what is going to be F dash minus F? So can I write this as delta F is equal to F multiplied by V plus Vs divided by V minus VL, right? This is the value of F dash minus F. Now F can be taken as common. So delta F will be equal to F is common, and if f is common, so this is going to be inside, right? So it is going to be v plus vs divided by v minus vl minus 1, minus 1. Now I have to solve this one and then substitute. I should be getting my answer. So it is going to be delta f is equal to f multiplied by, here let me multiply these two over here, right? Taking the LCM. So this is going to be v plus vs. So negative sign and v, it is going to be minus v. Negative sign and vl, it is going to be minus vl. Yes, is this what we'll be having? 3.9 hertz. 3.9 hertz. No, no, I don't think so. It is 3.9 hertz. 3.9 hertz. No, it is not 3.9 hertz. Okay. So over here, divided by 1. But now here there is one thing that you have to remember. And what is that? Source and listener, are they both one and the same? Source, listener. So what is going to happen? Vs and Vl, Vs and Vl, can I take it directly? And can I cancel it? What is going to happen? Because look at this over here. So if there is an ambulance and it is blowing siren, the siren will go like this, and then it will reflect back, right? Yeah. So this is the source, and here the difference at this particular point is what we have to find out. You are not able to understand? Shall I repeat it again? Okay, so let me remove all of this first. Again I will tell you with a diagram, then I will come back to solving. Okay, so let us take it this way, right? And here there was a particular ambulance, and this is moving. Okay, so vl and vs both are one and the same, because it is the same ambulance which is blowing, and at particular, that particular ambulance itself, we have to find out what is going to be the difference of the reflected wave, right? Now so vl and vs both are one and the same, right? So how is going to be your vs, velocity of sound? It is on the left hand side. From here, this is going to be the listener I can consider, and after reflecting I can consider at this particular point this is going to be the source, this way. Of course it is going to be the same direction, but you can assume it as a mirror image, as a mirror image. So this direction, as in this is going to be negative, here it is going to be positive, here it is going to be positive. So when I simplify this one, I should be getting my answer as delta F is equal to V, and V will be added up. So it is going to be 2 times Vs and then divided by V minus Vs. And of course multiplied by F, multiplied by F. Now when I substitute all of them, I should be getting my answer, right? So when I substitute, what are the values that I have? So it is 2 multiplied by Vs. 2 multiplied by Vs. Right? So what is your Vs? Vs is 2 multiplied by F. What is your F? F is 700 divided by V. What is your V? V is 352 minus Vs. Vs again is 2, right? So 2 multiplied by 2 is 4, right? 4 multiplied by 700, right? 4 multiplied by 7 is 28, followed with two zeros, and here it is going to be 350. Now I should divide both of them. That is going to be the change in frequency. Where did this go? It is over here. 2800 divided by 350. So it is going to be 8. So as in 8 hertz is going to be the difference. 8 hertz is going to be the difference. Okay. What is the difference in apparent and actual frequency? So it is going to be 8 hertz. So these are the types of problem that you can get from Doppler effect, right? So essentially most of the things which are in your waves I have discussed, and again I will be sharing all of this with you. Is it clear? Have you seen whatever I have shared until now? Yes, right? So if you have any questions you can ask. If not, I will be ending the class over here. Okay, thank you for joining everyone, and let us meet tomorrow. Goodbye, and I will share right away on, you can see it on the group. Yes, have a good day ahead. Bye. Welcome.